Hello everyone, welcome to this Leetcode video on problem number 1396, designing the underground system. So here we're essentially given a class with three methods defined corresponding to use cases of the underground system. These three methods are check-in, check-out, and get average time. So check-in is when a customer with a certain ID comes to a station at a certain time t. So let's say in this example, Leighton, he has an ID of 45. He checks in Leighton is the station, so the customer with an ID of 45 checks in at the Leighton station at time 3. And then these other customers check in at these stations, and then there's a checkout period where Leighton, with the same ID 45, not Leighton, sorry, the customer with the ID 45 checks out at Waterloo station. So he started at Leighton at time 3, he came out of Waterloo at time 15. So what we're asked to do is to get the average time of it takes for customers to go from start to end. So for example, if multiple people went from Leighton to Waterloo, we would get the average of their times that it takes them to go from A to B and print that when this is called. So our method could be, our check-ins and checkouts will be called for each customer that goes through the different stations throughout the day, and at any given point of time we should be able to get the average time that a customer takes to go from station A to station B. And here, if you read this, it's stated that we assume that it's all valid and consistent, so we won't be called with a checkout for a customer who hasn't checked in, or we wouldn't be called checkout with a earlier time than when they checked in. So we don't need to care about all those validations, and we can just focus on solving the problem. So first, let's see how we're gonna approach this. Now, at any given point of time, we should be able to give the average. So let's work, when designing our data structures, let's work backwards from this, because these two are just providing inputs to the system. There's no output, it's void. Whereas this one produces an output. So we need to have an efficient way of being able to provide this output. So if you look at this, at any given point from start to end, we should return the average. So we need a data structure here that can store basically the times that it took from start to end, right? So if we have a map where the key is the start station and the value is another map of end station to something that can get us the average, right? I'll just put it as a placeholder for now. So this is basically start time to end time to something that we're going to define, right? Now, what do we need to get the average? We could just either store the average, but if we stored the average, we wouldn't be easily able to populate this map, right? Because when a customer checks out, we should be able to populate this map with, or update the map with a new average. And just by storing the average, we wouldn't be able to do that because we wouldn't know how many people have already checked out previously, because average is basically a sum of all the people over the count, right? And if we don't have the count, we will not be able to tell what's the new average when one other customer checks out. So what we'll store instead is, instead of storing the average, we'll store the sum and count. So this way, when a customer checks out, we'll get the difference between his start time and end time and store that in the sum of all the times, and then a count, we'll just increment it by 1. So when we get the average, we'll just divide the sum and the count. So to store a sum and count, I'll use a pair of integer and integer. So this is going to be start, or no, sorry, this is not start time, it's start station to end station to sum and count. Now This pair class is in Java, but I tried in a couple of other problems and Leetcode doesn't support it. So I have one ready and I'm just gonna paste it here. So here's my pair class. This allows me to hold pairs of different types of values. So in this case, it's a pair of two integers, right? So now to get our average, what we're gonna do is simply get the pair of sum and count for the start station and the end station. So from here, let's get the start station, and that will give us this map, and then from there we'll get the end station. So this needs to be a map because there could be multiple end stations from a given start station. So for example, from Layton, one customer could go to Paradise, another customer could go to Waterloo. So we want to be able to store all those combinations in the map. So yeah, this will give us the sum and count, and then we just return sum and count dot get left, which is the sum, and sum and count dot get right, which is the count. And we don't need to worry about these missing because they already say that the call to get average time is valid, so we don't need to worry about zeros or calling us with stations that don't exist. So but these are two integers, so this will do an integer division, so we should convert it to double, so it actually returns a valid average. So this will take care of get average time. Now we just need, the next thing we need to do is populate this map. So in order for us to populate it during checkout, we would need to know, to be able to fill in the sum, which is the sum of the time differences, we need to know when the customer checked in, right? So we can't fill this map unless we know when he checked in. So during checkout, we need access to when did this customer check in to this station, and for that we need another map which we'll populate during check-in. So whenever a customer checks in, we'll store, okay, this customer has checked in at this time, and then during checkout we'll check him out. So let's create that map. So the map is gonna be, so this one again is start station to end station to sum comma count, which is the average. And here what we're gonna store is the customer ID to the station that he checked in and the time that he checked in, right? So it's gonna be map of an integer to another pair of, this time, a string which represents the station that he's checked into, and an integer which represents the time when he checked into the station. So this one is going to be ID to start time to, sorry, ID to start station to time, right? And here I'm just going to rename this to start station and end station so it's easier to read. So here we're just going to populate this map, right? So we're going to say ID to start station dot put ID, and we're going to create a pair of start station and T. So here we've stored, when the customer checks in, we've put him in this map saying that this customer has checked into this station at this time. So here we have all the history. Now when he checks out, we'll be able to look him up, right? So let's now get the start station and time by looking up this map. Dot get ID, right? and then let's just store them separately so we have access to them. So the start station is that dot get left, and then the start time is that dot get right. So now we have the start station and the start time, and then we can store the duration of his trip, which is basically t minus start time. So that's the duration of this trip. Now this start station could have so now we need to populate his information in this map, right? So this start station could have other end stations already, or this could be the first end station. So the first thing we need to do is to see if this map already exists, and if it doesn't already exist, we create one. So let's say if not start station dot contains key start station. So if the start station is not already in the map, then let's add a new map corresponding to that station, new hash map. So this will just create a new hash map to start putting our end stations in it, and if one already exists, then we'll already have one. So now that we have that, the next thing we need to check is if there are other passengers that already went to this end station. We would already have existing values here, right? So for example, if I'm going from Leighton to Waterloo, if someone checks out at Waterloo, there could be two cases. One is someone else previously already been to Leighton to Waterloo, in which case we would have their sum and count here, and the other case is if it's the first time, right? So we need to handle both cases. So first, let's see, let's initialize our existing sum to 0. So this is the existing sum. If there's any existing people, there will be a sum here. If there's none, it's going to be 0. And existing count let's also initialize it to 0. So if this is the first passenger that's going, for example, from Leighton to Waterloo, existing count will be 0 because there's no one else previously. And if it's like the second or the third, we'll have something in existing count. So we'll initialize it to 0, and then we'll check to see if someone has already been there, right? So the way we can see, so if this dot get start station already contains end station, right? So if the start station's map already contains that end station, that means we already have values for it, right? So what we're gonna do is then we're gonna get the existing sum and count, right? So this is the existing sum and count is basically this, but change this to get. And let's wrap the line here, or let's okay, our variables are too long, but that's fine. So the existing sum and count, if the end station already exists in the map corresponding to the start station, that means we have an existing sum and count. So we'll just set our existing sum to existing sum and count dot get left, and then our existing count to existing sum and count dot get right. So now if none already existed, we initialize it to 0. If someone has already been to those two stations, we now have the sum and count that existed. So now we just have to go and create the new sum and count, right? So the new sum and count would be what we're now updating the map with. So this is new sum and count. So to get the new sum and count, what we're gonna do is existing sum plus the duration of this trip, right? And existing count plus 1. So this adds the duration to the sum and plus 1 to the count, which will then help this function get the right average. And so with that, then the last thing we need to do is just update this map. Update the start time. So let's get the start station. So update the start station to end station with the new summon count. So we get the start station map, and then we put end station new summon count, which will update the summon count for the end station. And then once we do that, since this customer is already checked out, we can also remove his entry from here. That's not necessary, it's just saving space. I meant it's not necessary for correctness, but it'll just save space. So the ID, we remove the ID since he's already checked out. And that should do it. So to summarize, when he checks in, we save what time he checked in. When he checks out, we get the duration of this trip by checking what time he checked in. And then we attempt to update this map, accounting for the cases if there were already people who went from start to end. And then once we have the new sum and count, we add it to the map. And then to get the average, we just read from the map, going from start to end and dividing the sum by the count. So let's see if this works. So we got a null pointer exception in check-in because obviously we haven't initialized any of our maps. So in the constructor, let's just go ahead and initialize our maps. And these can't be static actually because they should be initialized with every new creation. So let's look at that. Okay, it looks like we produced some correct results, and submit. Cool. We got pretty good results, so I hope you enjoyed and learned something from this video. I'll see you in the next one.